advisor.
Trust me, I have.
You have?
I
know how to.
I know. I
Because the first one, my practice of my algebra
Where mine is 3 times plus 5.
like couldn't.
Add the
Yeah.
remaining.
Yeah.
That's the formula.
I'm not that bad.
Usually how it is.
What's up, bro? A little bit.
Alright guys, listen up! Have your attention. When we get started with class, can you please put your test away so you're not distracted with it throughout the class? We don't want to be fighting for your attention. Now, as usual, we have some general announcements. Our object concept review is going to go over a few things we learned in the beginning of class and like the beginning of the year. Throughout the rest of the year, we're going to start transitioning the algebra concept review to a final concept review. So we're going to start going over stuff we learned in the beginning of the year that you guys have forgotten, because you guys forget. Today's lesson is we're going to go over more of the basics of functional inverses, and then we'll finish up with a post-knowledge check. One more thing, for the people who just walked in, we are having this session filmed. No one else will see this. If you have a problem with being filmed, sit towards the back. You more than likely won't get on the film. One of our bosses can't attend our session, so she asked us to film it. That's why we have our beautiful cameraman over there. Jeremy. Now for the announcements we have, the Chapter 5 50% Pi completion is due Thursday, April 13th. It's not a Friday, so don't worry about it. Chapter 5 is due Tuesday, March 24th, and then your test 3 is on April 25th. Tom?
The check for us through March.
And it's supposed to be April.
And you can ignore that last announcement because Open Lab is no longer.
Is it?
Right. I'm pretty sure it's like.
Is it no longer a thing?
I haven't heard that.
Okay.
Don't ignore the last
Never mind, don't
announcement.
ignore the last. That's just what I
So on every Friday, to our knowledge,
We still don't have time. Class ends like.
Yeah, we can't really go to it anyways.
okay, we're going to switch over to your ACR, which is, we're going to go over the vertical line test, which is something that Dr. Graham touched upon in session today, in the class today, and we also did some in the beginning of the year. So, right now we're just defining that a function will pass the vertical line test, which is just a vertical line from any point on the graph up. But also, we're going to look for one-to-one functions, which is something else we learned in the beginning of the year. That has passed both the vertical line test and the horizontal line test, which is just at any point you draw a horizontal line. If it hits the graph again, it's no bueno. So, is this a function and is it one-to-one?
Yeah.
Yeah.
Yes? Okay. And yes for a function and yes for one-to-one. How do you know this just looking at it?
Passes both the vertical and horizontal lines.
Yes. I'm glad you guys can retain memory.
No, it's something.
Yeah. Next one?
No.
No, it's not a one-to-one function.
Is there a way you can make this one-to-one?
Huh? It's not a one-on-one.
It's not.
Right.
But like, what if
If
we?
you were to rotate it,
Okay.
No, because if you rotate it, it wouldn't be a function.
right side.
Right. So he's saying if you rotate it, it might not be a function anymore. What you can do though is you could restrict the domain of this function. So if we only looked at certain pieces.
One quadrant.
Right. So if we were like page side, if we were to just cut it off and just look at quadrant 1, then we're going to pass both the horizontal and the vertical line test. We've restricted the domain and we've made it a one-to-one function. Cool. That'll come back. So
You may or may not see this in the next 10 minutes.
So we will say in the next 10.
Yes.
I said may or may not.
Yes, no.
Yeah. It's a
Does everyone
function.
agree with that?
It's not a one-to-one.
It's a function, but it's not. Yes.
Alright, cool. Yes, no. Now, yes and no, again.
No.
Now, what about this?
Yes.
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 Yes and yes. Why is this yes and yes, but the last one no, yes and no?
That's just
Did you
Yes.
restrict the domain on?
Yes. Austin jumped the gun a bit,
I did.
and we want to clue you in on a little secret. You can restrict the domain, so it's 0 to infinity, and that will give you a one-to-one function for parabolas. So you restrict it at the beginning or wherever, and it just goes for an infinity. I'm bad at words. Now, is this a function and one-to-one? Why do you say that?
I can't pass the horizontal line.
Yeah,
Doesn't pass the horizontal line test I heard?
it doesn't.
It doesn't? Awesome. I mean, yeah. So what about this?
Yes, no.
Yes.
I mean, yes, yes.
Yes.
Yes, yes?
Yeah.
Yes, yes. Awesome, you guys are doing great.
No, I mean, yes, no.
Yes and no.
Yes, no.
Yes and no?
You
Awesome.
run too fast though.
Jumping the gun a bit.
Yes,
Yes, yes.
Yes.
Now, why is this yes, yes?
Because the domain was.
The domain is
It
restricted.
can't be a time limit.
Because what both Paige and Trevor said, we restricted the domain of this, so it only goes from a certain interval. Can you go back to the last one? We're not going to test you on what this graph is, but does anyone have an idea what this graph is, like sine? We're not going to touch upon this in class because that's pre-calc 2 stuff. It's just to get you familiar with what a sine graph looks like. Yes, you are correct. This is a sine graph.
I was gonna say, you don't have to worry about this till, like you said, Math 168, when you do like inverse trig functions, like inverse sine, inverse cosine, that kind of stuff.
We're not going to
Don't
scare you with
even
that right now.
forget what I just said.
That's going to come next semester for you guys.
Yes.
Yes, and yes.
Anthony, do you agree with that?
Yes,
Why?
because it passes both the vertical and horizontal line test.
Alright. Then what about this one, Anthony?
Yes and no.
You said that pretty quick. Are you confident?
Yeah.
Alright. Does everyone see how this is a yes and no?
Yeah.
Alright, cool.
No.
Yes and no.
Yes.
Yes and no.
Yes.
Or
Yes.
yes. Yes and
Yes and
yes.
yes?
Yeah.
Alright, cool. So now that that is done, we're not going to have you guys draw because we forgot the,
Whiteboards?
not the whiteboards, we had graphing paper for you. But now we're going to move on to a packet we have that goes over the basics of inverses. I know we did a little bit of the basics in class, but this just reinforces the idea. So either work with the people in your row or with the people around you. Don't be afraid to talk. I know some people are. And we will be circling around we will be circling around the room to help you guys out on this. I'll give you one too many. Go.
There you go.
So turn around, work with the people around you. We will go over this in like 15 to 20 minutes.
Since I'm like, I didn't want to go right back. Okay. I'll walk around the house.
Remember, we don't want to see phones out. If we see phones out, we have to take off participation points, and you don't want that. Especially around this time of year, because people are starting to realize, oh, it's nice outside, let me not do homework. You should still do homework. You still need to do your homework. What? But
It wasn't nice. That's
yeah, it looks like it's about to rain from the last time I looked outside. It was raining.
Well,
It was.
I was just on there.
They started on this.
You need help
There.
with this? Do you understand this?
Trying to be as
Jeremy, can you hand me the yeah, that. Thank you. You're welcome. While you guys are working on this, I will pass out the homework from last week so you guys can see what you got.
Well, the one allows it to pass the vertical interflow. It might be made up horizontal, but either way,
If you guys have any questions on the homework, feel free to ask, but make sure you're focusing on the worksheet at hand.
then it's a one-to-one space. But then it doesn't go through more than once, so if it's going through like this, it's not one-to-one. It can only pass the vertical. So.
Feel free to talk, you guys. We're not like holding you in court. You can talk to your neighbors.
Yes.
No,
Like, restricting the domain in a function that's not one-to-one, one-to-one.
You sure he's responding?
So number function is always lower. And once you get to number, I think once you finish, yeah, once you finish the first page,
They say the allergy medicine is not ground, but I still every time I take like go to sleep, it's like an allergy medication.
Every show we make ourselves alive until like 12 hours can be good. So I'm trying
What happened?
how are you doing?
What would be the solution of inverse function?
Allergies. Allergies are taking away from math. Yeah, you have to pick your allergies. So is it everything's in a blur right now? Is everything in a blur? Do you need help with this? Too?
I need an SDP.
Okay. So
What is this work like over?
how does he answer the question?
yes.
Okay.
So
So
like, so the first one I said was
Is
just
this?
that's one.
So what is
Which one did you say was? So this one is the original one. And then the one that has the horizontal line test and the vertical line test, so since this one does, that's good. So now we have to reflect it over.
change in
Well,
line, how much did y change?
How do we know, how about we skip this question and come back to it after you solve these? That would help.
6 to 5, how much is that? 6, right? So it's the change in line. It's how much y change. I just use these two.
Well, for this, we're just looking for the original point.
Oh, once it's line.
No, not for that question. You may or may not need to do it later on. For both ones, yes.
Well, wouldn't it be, let's see, is the original or is it just the line?
Are they?
Yeah.
Are you sure?
Yeah, you can go on to the function, it's always y equals y squared.
Well,
They're all inverses.
well, you need to make sure by actually solving it.
It's just kind of explaining words that like.
That's fine, I just read out like.
How you doing?
Right, so
Good. Do you have any questions?
subtract, what's the opposite?
How many of you need? How are you two doing? Great. How are you? Good. Understand all this already?
So now,
What's gonna reverse this? This over one, and this is over this y divided by two, right? 1 times y is y, and 2 times y is
this is not cool, we're
So it's gonna reverse this y is negative.
That's fine, but we have to write it.
Operation is this. So addition, subtraction, multiplication, right, it's division, very good, right, so instead of getting divided, so what's gonna reverse division?
over.
Multiplication by
Why aren't you doing
So
that?
then we'll let you do this, multiply this whole side, and that's where people are missing, it's not just the gap, but the whole side. If I multiply this side by 2, I can multiply that whole side by 2. So now these would cancel, right? So
1 over 6,
yes.
1 over 3. Yeah, because when you simplify it, it's 1/3.
Alright.
So let's just see.
Is it 1/3?
If that's the case, is this a solution? If I put in a 3 for x,
Yeah, it
that's
is.
12.
It stops, okay.
On x is 3, it's not
Gotcha. Make sure that everyone here is understanding.
We got it, we're good, right?
Well, we're not on us, but
Or you would have to
probably
square
start
that.
that.
No, you have to add it first, and then multiply by 2.
Good scaling.
Here, but then I was just checking to see if I got different answers for that. Unless my math is somewhere wrong. Because this one.
Yeah, you can use either
Did you
one.
just flip these?
No.
Yeah,
I used-
if that's one you're familiar with, yeah. Do you understand how to use it now? or did you know? Okay, that's it.
And then, how did you get this plus?
Checking it.
There you go, that looks good, right? Yeah.
But you have minus.
Oh, yeah. Oh, I just put it 2 for some reason.
I must have just copied over everything.
Good for you, right.
Yeah.
But now,
And I'm a
this,
terrible
go
speller.
back
Oh,
and
it's
check
somebody,
this.
vertical is
So then.
T-I-C-A. Yeah, but it doesn't matter. I'm a terrible speller.
I usually just write like
A lot of people spell like that, yeah.
horizontal
How you doing? Makes sense?
If I was the victim, I can't be the perpetrator anymore.
Getting there? Let's start off.
This is, gonna walk through this.
Can I help anybody here?
It's the integrated
Good.
function.
About here, any help? Yeah.
Okay, I got that result, okay, so yeah, I plugged it in,
And how'd you get
that's
there?
like, is that what saying you check, by plugging in the inverse is on?
Well, you could always plug,
Which one was the flex?
So your slope is?
well, this is saying you can do the composition of 2 functions. So you can plug your this into this, and then what would you get for that?
Oh, I see.
And then you have to do plugging this into this.
1 dash x
You got y is equal to 2x plus 6.
plus
You show me how.
And then you have to also do it for this and this. So this, or,
this and that.
yeah.
Yeah.
So the 1 dash 6.
Right. And then after you solve all this out, you'll figure out, you'll see something,
Right, now let's test it.
and you'll see a pattern, oh my god. And then, the world will make sense.
This means if I put in, 4, which one? I should get out of the 4. Right, so let's just
Oh,
see
you're
if I
right.
put in 12 for x.
Confirmed.
Will I get out of 3 for y? Is it? Right, now how can I actually do this for all?
Yeah.
That just tested 1.1 for 1. That doesn't mean it's I gotta test this feature, what's the all? Why is that the answer for your last one? So I'm able, how can we test these are real inverses? Well, instead instead of specifically filling in.
Your word in the segment?
I don't know how to do like an actual.
We don't want,
Okay, good.
for once, we don't want
Okay, I
ours.
thought it was like just words.
Well,
What is this?
you already have an option.
We don't know, that's why I just said the line.
Okay, so,
Yeah.
You just said what it was.
So,
well, we know that this cross is zero, and this point is one. So we can say that the line has, you can have a bunch of times like here and like intercepts of it.
Well, that's why the second one didn't plug in.
What are we
Oh,
doing
yeah.
that comes out?
This will match all of these.
Yeah. We're all done.
So what is this line?
Isn't that the?
Isn't that our original?
Flash
numbers
later, you don't-
Okay,
so we know that one of these lines is being reflected across this line.
This line.
Right, or vice versa. So once you figure that out, you know that, oh, this and this are the same line.
Break this down,
Bingo, we got it, right? Yeah. What is that?
This is the dot.
See, I'm overthinking that.
What is up with this?
What I do.
Austin?
But I was
Right,
taking
so-
the complex form that we were doing in class and then trying to
Right.
apply it here, and it's, in my mind, it wasn't
Well,
working.
if you solve for both of these, if you solve for the inverses, and you put those ones together, you'll get that. Unlike y is equal to x, and that would be your reflection line.
Oh, that's okay, so it's the reflection.
Yeah.
That's the pattern.
And then that should work for any function that
Highlight, right?
You're graphing this.
reflection.
We got it right, right?
Does that make sense?
Yeah,
Wait,
yeah.
you got it, yeah.
Okay.
Sure.
That's just, I wonder how to know what.
Gotcha.
Because I said it in the diagram, but I was like, I don't know.
You explained it.
So, has mostly everyone gotten to number 5 at least?
Just got to 5.
Just got to 5?
Yeah.
Working on 4.
So,
Guys, listen up.
When it
Listen,
comes-
Austin.
when it comes to functions and their inverses and graphing them, on what line is an inverse reflected from the original function?
The reflection
The reflection line, where is that?
line. X.
Where? You can have it.
X?
X?
Yeah.
Yeah, at y equals x.
So it'd be like y over x equals x.
Yeah.
Yeah.
So if I'm going to draw this line right here. And what's wrong with this function?
It won't go.
Right, it's not 1-to-1,
Yeah.
so we shouldn't be able to get an inverse out of this.
Right.
So I just wanted to show you a quick visual representation as to why we won't. If we were to flip this graph over a reflection line, y equals x, we're going to end up with something that looks like this guy, right? Like that. This part gets flipped up there and this whole part gets flipped down. And is this a function?
No.
No. Okay, does that make a little more sense?
Yeah.
Does it help seeing it this way, kind of? Okay, cool. I think now we're going to call people up to the board.
Right, so we're gonna call people who are done with the problems to come up and write how they, not how they solve, but their answers for the first question. So, if you don't volunteer, we will call people at random. You guys can still work, we just want you to put the answers up.
I think Teresa's itching to do it. No? Go look at it first?
Are you?
I want to do
Just say no.
I want to do 3.
Alright, so Zach's gonna put up everything for the first set of for the first graph.
So like the whole.
Or just from 1 to 3.
I'll do 4. I'm over here like, I got this. I can do 5 still.
1, 5? Okay, go for it.
You want me to do it now? Not after we done like 1, 2, and 3?
Do 1, 2, 3 over here, 4, 5 over here.
Okay.
4, 5 there.
Yeah, 4 and 5. 4, I was thinking.
Sit down. View the camera.
Oh, here it comes.
Just keep on working on this packet, and then the answers will be put up on the board eventually.
There it is.
Okay, so if you did x2 minus x1 over y2 minus y1,
So I'm just doing it.
right, it's 2.
Are you done?
But if you know that, oh,
Not
I accidentally
fully.
flipped these,
Not fully.
like
Like I just, there's just
flipped
like
them accidentally,
one or two
then
problems.
you can just flip this, right?
Yeah, it's
The
just,
opposite
it's just saying the.
Well, we can also flip this, right? So it'd be 3 over 6.
Austin.
Yep.
And then what is that?
Is number 5 just basically summing
third?
up everything that we did, between 1 through 4? Pretty much? Because it's just saying describe how the graph.
So does that make sense?
And the results.
Okay, and then from there you can find the slopes of these.
Well,
I'll call it something.
Just like regular, it's opposite.
kind of like what
Reflection.
The first 3.
Reflection, that's what I was looking for. This is what reflection is. If I were to
one
pull
graph
right here, you see that when it goes over I held this up to the light, it's the reflection.
Oh,
So,
that's a reflection.
You can, do you mind putting 1 through 3 next to this graph? So Anthony's putting up the answers for 1 through 3 on this graph. We will get you a marker now.
Y2 minus Y1 over X2 plus X1.
yeah, I think that one's.
That's not even
Do you need help? Negative 80. What is it? What's that thing called? What sits in front of us?
How you doing? Taking science? That's like part 3. Go back.
Number 2. So what did you say?
And you said the domain is restricted, which is close, but if you take a look at each one of these, this, and this kind of just switch X and Y. Does that make sense? So they're not being restricted, they're just flipped.
Still be one, because the actual graph.
The inputs of one function is the outputs of another. Does that make sense?
The actual slope of the graph is the same, so you can't just go from one to one.
Is the slope of this graph the same as the slope of this one?
Technically, but you're just looking at it from the direction.
Right. So you can't just flip them out. This one's zero. So the slope is changing.
Oh, yeah, that's like, it's not like. Look, if you look at it this way, it's the same slope.
But you also don't give a range.
I mean, it's kind of makes sense. But,
Yes, range. You may see how the and the range.
so,
Oh, well, you can also change the parabola
Yeah,
to
so
right,
you would do the.
to the side, right? So
Yeah.
that means that it's not being
right. The parabola is not one of
How you doing?
Ish.
right, but it would if you flip it on the side. For flipping up, right? Flip it on the side.
Okay, see that you compose these two, and you just get X.
That's what I'm saying.
And then you move over here.
Well, yeah, so that's kind of, it's pretty close to like what.
What do you want the end?
Right?
Basically, I mean, you're right.
And then that will be in the line that you flip, right?
Right.
You do the same thing.
Right.
Is it the
One.
same
So
as,
now wants to know what function has an inverse and
like,
has
it would
this
be
answer related to function.
6, 6,
Yeah.
12, 12.
So the way I phrased it, which are both three, so there's exactly one input output.
Is that what it's trying to say?
It passes both.
Yeah.
you just take the X from the one and the other?
No, you distribute the two.
Yeah,
Just make sure you're on the slope.
but you can also draw your little
One half is
line to the next line,
right.
and you see, oh, like this over this, like it's just
Going in class,
and seeing that. So this, all this is trying to show is that,
all real.
oh, this reflected across this
Good.
axis.
And then you do the same over there.
Yeah,
See
it's
if it
this.
matches it. If you get an apple here and you get an apple there.
So, what was the?
What do they think?
Horizontal line test is to see if it, okay, this
So
one
if it goes over the line,
Passing through
They are
Yeah,
inverse.
so this line here, right?
yeah, horizontal line test is only there to see if it passes both the horizontal line test, which is, it only passes the same graph once, or it doesn't pass the same graph, so if you go horizontal line,
That's why.
and it passes the vertical line test.
that's just one.
We know that that which is
Black and white, white and white.
So what if you have a regular?
yeah, if it only hits the graph once, horizontally, it's a one.
Oh.
And
But, yeah, it'll like this. Yeah. Just flip it over the axis.
Is this graph intended to be like going on and then off the page?
Yes.
It
goes
on
forever.
Is the way that you can.
Alright guys, the answers for 1 through 3 is on this board over here, and 4 and 5 are on this board over here. Compare your answers, see if you got it right, or if you have any questions, feel free to raise your hand, and me, Austin, or Dr. Graham will come over to assist. Continue working.
Over 5. I mean, probably. We can probably.
So you're just confused with this part? So this is pretty much the sorry about that. So this question is pretty much asking you to compose this function into this, and then well, not well. You can do that. You can. Yeah, we're trying to get this. How you doing, Kat?
I think you used the wrong equation. Because, yeah, did you use the, equation with him?
So what's the range? It's all
Well, yours is not.
It's all values, why you do what's the smallest y down here?
Under this guy?
Great idea that was, huh?
And then 1 or 2, I know it's easy. And mine's right, so I
So you'll
don't know.
put the slope in for your, your slope is 2.
And then what's the
And then
height?
you take any
For
random
this,
coordinate.
it's just asking for the range. It doesn't have to be.
Right?
For this guy?
Now what else do we have?
This is your x.
G and F. And this is, these are punts, we don't know. Every time we got a really precise graph, I don't know what's there.
This is not,
Yeah, right,
So
but
you're
you
gonna
get
have.
the idea. Right on there.
You see how like this one looks
When
like.
it's not equal,
That's
so
all we
let
that's
me
where we
show you
go
an
with.
example.
That's horrible. I don't even buy that. No,
Alright, you see, this is all Johnny takes off.
Now, it's not right after 10, so that
Right.
Yeah.
And then they
The domain is at this point the range is at that.
Yeah, I'm doing a one estimation.
Yeah.
Just going off of.
Well,
This is used to get to this.
Is it
And then this helps you determine what your slope is. So in this case, our slope is 2.
I know
Why
the graph.
Yeah.
Look at this graph.
So that's why I was doing
Intersects
like
this
Right. I do agree that it's hard to tell.
Yeah.
But
So now we know.
they're trying to show you that these
Yeah.
the domain of 1
Mhm.
is the range of the inverse of it.
Like the functions you got are in
The range,
this.
so if the domain is the range of the inverse,
Yeah.
what is the range? The range is the what of the
No, we literally just got.
So I guess try it again.
Yes.
With the
So
Just letting you know.
it should be
What's a
regular.
realistic application?
We were joking because we were talking about something else.
Yeah, that's
and
cool.
I came over and looked at it.
This is
So we tried to do it.
Because we're not taking the inverses of
Would
this.
it work the
Of
same way for
negative.
like if I tried it for another one, or do you think it's
This is
just
the
fine?
data, this is the.
I wrote
I mean,
it.
What's it a little
I wrote it
Which you
down
could
here,
do,
so
if you
I
wanted
could
to use
use
this.
It doesn't really matter as long as you
Determine your
communicate
slope.
your
Determine your slope was 2, right?
That's,
And then
I did, I
I'm
wrote
looking at this one.
So
What's your
the
y
reason why
intercept?
it's not
So that's your
negative.
b value. So you can just do
This
2x
is
plus
the
b.
dotted line.
That's your function. So now apply that to this. What's your slope?
negative,
Oh, the two, yeah.
this is,
Right, so what's your
Okay,
slope?
G is the dotted line.
What?
yeah,
So we can see that the domain
Okay.
starts
You lost
like
me
here
there.
So-
and is positive.
yeah.
So calculate your
So
slope
it
for this line.
so it doesn't
Okay.
go
And then
here.
what's gonna be your b value?
So then it would just be 2, so then
Negative 3.
it's going to equal the range
That works like
of
graph.
the
Right.
other.
So we can do like a little arrow graph like this to show that they are equal. So if you can find the domain of one, you can find the range of the other.
Yeah, it's 2 then.
It's infinity. These are just, the barriers don't mean anything, they can go on forever.
Yeah. So what you're gonna do is you're gonna come up with any random point that you want. I did 2, 0, and negative 2.
Okay, that's
No,
And
it's
you're
not
gonna plug them in,
negative.
and you're gonna just take what you get, and you're gonna put them in your corresponding
Well,
box. Then what you're gonna do
I
is
don't
you're gonna
know.
take the y values from
The
this one,
question
and
would be,
you're gonna plug them in as your
looks
x
like
and
it's
y.
either
And
negative
you're
one,
gonna see what ones.
but is that solid?
Okay?
We can't tell. So is one part of, I don't know. So I would say it's a 1. We don't know, the graph's not enough detail to read.
Yeah, so,
This is part 2?
yeah. No, it's not that. Yeah.
Did you have a question?
Yeah, you're gonna, yeah.
Just
Can I help you?
My brain's
override or overdrive?
Just like how.
Overdrive is good, override is bad.
When you were out there, this would just be 0, right? 2 minus 2 is, 0 squared is, has negative 1/8 is. Minus 1 is
Yeah, you gotta
negative
do
1,
something.
right? So now,
But is this
what would
making
you
sense to
tell?
you?
It does make
So yeah, the domain
Put in
is,
over here for
yeah,
us.
2 to infinity for the first one.
Yeah, and what do you hope it comes out?
You'll see that there's a.
Well, you can still use this. Did he yell at you for that? You can use this.
And you could, if you wanted, and you would get the same answer, but you understand, you get, I can do what's in the board of operations tells me I can do.
I don't know too much. Give it a tell.
Right when you're reading, you just don't have the right
Board of
wording.
operations, you get like.
So I think it's spelling like X. The X is an equation. Yeah.
Well, because this is the y-axis, and this would be where it intersects the y-axis.
Yeah.
So that would be the y. Yeah, still work out. Anything? Doing okay there?
Oh, yeah. I got what.
You understand that?
Understanding this.
Mark, how about you? What do you need help with? From the tests?
The composite.
Well, that's what you're doing here.
Well, no, I'm thinking he's saying about like this.
Checking it, right?
Yeah.
By trying f of g of x and g of f of x.
Yeah, I actually overthought
Can I
that
just-
more.
Well, here's my advice. This is how I
Are you done, Anthony?
functions, here they are, right?
If you guys get going with this packet, we do have more worksheets for you guys. This will be more of what we covered in class today.
I'm not done. Like, probably.
Well, I shouldn't have told you.
Let's keep working.
Well, now you have to finish the first one, and then move on to the second one.
I just count.
What's yours?
Mine's in my backpack.
Then what are we gonna do with the G function? Do I erase the
Yeah, then,
X? Right, okay. And then what do I do with the G function?
It might have been just not having numbers a whole lot to input or just visualizing it. Because that's what I did. I actually overthought it. I was looking at this and I was thinking,
Yeah.
how am I supposed to solve that? Because I was still thinking about when we were going over classes. That's one of my faults.
So how do we know in fact if it is an inverse function?
Everybody get it? Do 1 through 3?
does everyone have the answer written down for 1 through 3?
Yeah,
Any questions about them?
not currently.
No. Cool.
Okay, we're gonna erase it, because we're monsters. Austin's gonna be showing you the answers for part 2, after he draws everything.
Are you sure? Because I got plenty of
Did you forget in Cincinnati?
No, it's in my bag.
Oh, you scared me for a second.
It's at my house.
You just keep
It's
going.
at my house.
Just go down to the store.
I'm just gonna walk this way.
It's supposed to be
Way out.
Is everything?
No, I know.
Just run. You will have to take some lessons. What's that? You can just pull some points off this.
Am I putting it in the air?
Right.
I put it here and then stick it through this and then I feed it wide.
Yes. And then take these wide out and put them.
And then replug it in that shit.
Yes.
You should. If I was to get my X over here, I'd get my Y over here, keep it wide.
You look respectful.
Yeah, the pie, right, so that's one.
1 divided by 8, so you put that in its own sector, and then with it being next
So
to
what did you see?
another parenthesis, it means
How about we try these?
minus 1. Right, that way
So
that's
Okay.
How you guys do?
Yep.
You know, SBT
What?
prior to
Yeah.
the test.
That's
Zero, 1, 2, 3, that part.
This is where we need to go. We can't get it going, I don't know. It's up in the ceiling, the document ceiling.
Really?
Yeah,
Never seen one like that.
me either.
All right, so I got a really rough sketch of the graph for part 2.
Really rough.
It's not my best, but I tried. So first, it looks like I'm looking for the domain and range of this function. So can anybody tell me what they got for their domain? Yoli.
I got -1 to infinity and then 3 to infinity.
That's that for
The original.
this one?
Yes.
Okay, so which one of those is your domain?
Oh, the -1 to infinity. That's the domain.
Oh, you're right, I have it backwards.
Yeah, and then the range is 3 to infinity.
My bad.
It should work out because I got the opposite for the other.
Yep, yeah, you had it right.
Yeah.
Alright, and the range you said was 2 to infinity?
I am not.
Okay, I have the opposite.
That's for the other one.
Is it?
Yeah, that's pretty
That's
good.
for the solid color, the solid one.
F is the dotted line.
That's for the solid one.
Is this for the solid function?
Yeah,
Yes.
yeah.
That's 2.
Oh, it doesn't.
So that's asking for number 2.
How do you know to include?
Oh, okay. F is the dotted function.
Yeah.
I mean, you can just flip them.
You're
That was me.
Oh, see, you're already ahead of me, so you.
You can just flip the name.
I could have just flipped the name.
Yeah, I'm sorry.
It's okay.
I'm like throwing you off.
No, you're good. You're good. That's like a terrible infinity symbol.
How do you know that it's included?
I don't know, it was like either
Actually,
2 or
it's not like
3.
dotted or.
All right.
How did you get 2?
You
So,
don't see it open up.
this graph really isn't labeled that well.
No, I think the domain is -1 to infinity.
So
That's for the solid line, right?
Yeah.
Right. We're talking about the dashed line.
Oh.
So you.
The dashed line is the first one,
Yeah.
and
Oh, see,
then
I thought you.
the solid line is number part 2.
Okay.
Yeah, I don't want
And
to
then-
be picky, but I think that was
What?
either 2 or 3.
That's 2.
That's a 2. Okay, that's
It's a 2.
kind of lines.
All right. So if you read the directions, it says the 2 functions. F is the dotted line. We just F, and G is the solid line. All right. Label those. So this is the domain range of F. Does anybody know how Yoli and I got that? Right. Domain is my x values. So from about -2, you kind of guesstimate with how this graph looks. So from -2 to infinity is our x. And then our range is our vertical, or our y, and that takes place at about -1 all the way up to infinity. So now we're looking at that with our solid line, and what did we get? So what's the domain of our solid, or the G?
It's -1 to infinity.
All right. And our range?
It's 2 to
2 to infinity. All right. And what do we notice about these? They've been inverted. Our domains and ranges have been inverted, which makes sense because they're inverse functions. And that's basically the answer to number 3, was describe the relationship between the domains and ranges of inverse functions. They're inverted, they've been switched. Cool? All right, any questions? No. Let's see how much time we have. Oh, we have 4 minutes, so we can try to do our post knowledge check now.
Plugging your laptop.
Give her 2 minutes left. Is she alright? She's gonna set like She like turn off the computer.
No, you don't have to get out a half sheet. Don't have to. You do not need. Okay, this is a little activity we call sometimes, always, never. So we're gonna show you a question, and you guys can either answer with a sometimes, always, or never. So
Just yelling it.
Like out loud?
Just yell it.
Whoever yells it loudest wins.
no, you're not winning.
Yeah.
What's the difference between true and always true?
True and always true.
It's never not true.
So it can happen sometimes, it can always happen, or it never happens. Okay.
Why did you need a true there?
Makes sense.
Okay, guys. So
All right, it says sometimes, always, or never.
if it's a function, it always has an inverse. Is that always, sometimes, or never true?
Never.
No.
Go.
No.
Always.
Sometimes.
Sometimes.
It depends.
It's
Sometimes.
sometimes. Does that make sense why it's sometimes?
Yes.
Because we can have, go back. We can have a function like this cubic function, and if you work it all out, you get this monstrosity. And you can tell that this is most definitely not an inverse of this. So you only need to compose f of g of x or g of f of x to equal x to be an inverse. Is this sometimes, always, or never true?
No.
So you only have to do one of these, and if one of them is equal to x, it's an inverse.
No. Never.
Never?
Sometimes.
Sometimes? I'm hearing a never and a sometimes. It's never.
Sometimes.
You get lucky.
I mean, sometimes it works out that you know they're inverse, like using the points and stuff, you always gotta check.
Right, it's always good to check. So we have an example here where these are the f of x and the g of x, and it only happens sometimes, but they have to happen both in words. If you plug g into f and it equals x, you have to also check if you plug f into g and it's equal to x. I know that was a whole bunch of confusing words. Hopefully the pictures help a little bit. So one-to-one function will always pass the vertical and horizontal line test. This is sometimes always or never. Always.
Yeah.
Always. You gotta have both or else it's not a one-to-one.
What else could you do to make it a one-to-one?
Restricted domain.
So a parabola has an inverse.
No.
No?
Never. Never.
Never, ever, ever? Sometimes?
I mean,
If you restrict
I
the
just gave it
domain.
to you.
You have to restrict the domain for a parabola to have an inverse.
But then when it like actually.
But then it wouldn't be a parabola.
Yeah.
Yeah,
Exactly.
so it's
It's
basically
restricted.
changing.
No.
It's changing the graphic.
No,
It is.
because these two have the same function.
Is it still square?
It's just, yeah, it's still x squared. I think that's the function they use for this.
Yeah.
But they only restricted the domain of this. They still use the same function. So the only way you can get a inverse of the
Just.
Always positives.
yeah,
Bro.
yeah,
Greater than zero.
words. And then that's it. So thank you guys so much for staying with us. I hope you guys have a great rest of the day. Our boss.